design process well suited to cross-disciplinary instruction in STEM content areas?
Well, I see it in a way as like it's very similar to using the scientific method. So it's beneficial for conducting experimentation. It's like a systematic process where they can develop analysis skills, problem solving skills, and that helps the students, become more adept in learning mathematics as well. It all sort of ties into place. They gain that ability to, find solutions to problems. That's sort of how I think it's well suited for that cross disciplinary instruction.
I agree with you. It also gives them like a chance to make some errors and figure out where they're going wrong and have that self-reflection and metacognition side of things.
Exactly.
How will your PLC continue to support other STEM teachers while implementing the engineering process and evaluating its effectiveness?
Well, I wrote a little bit about that. Just basically, um, let's see. Basically, start by it's a continuing regular PLC meetings where teachers could share, what's working, what's not working for them, how they use like engineering, designing processes in the classrooms, stuff like that. Also, to support the implementation of the PLC, offering modeling with the co-teaching opportunities. For example, like teachers could demonstrate engineering designs lessons while, also observing or team teaching, building confidence and stuff like that. Um, I think, you know, I'm just reading what I put in my Microsoft words. And then, finally just, keeping the process going by reflecting as a group, like a group reflection, um, what improves students' learning, what needs to be adjusted, and what should be scaled across the classroom, basically. Continuing the cycle of implementation, feedback, refinement, and basically what supports meaningful, like to sustain, a good classroom management, stuff like that.
Yeah, definitely. I think talking with the PLC about what is positive and what isn't working and coming back and making those changes as a group and supporting one another with also like co-planning and modeling lessons and stuff like that. The last question, how will you implement the engineer designing process in your future practice? So for me, I plan to incorporate it by designing my math lessons around the real world problems. So stuff like we mentioned in our assignment, talking about the water filtration. So real world applications of math and science and any other content areas that they can kind of go through and test their ideas and see what works and what doesn't work, and then also reflect on their learning, the content that they're learning, and also um, what's working in their engineer designing process and solving those problems. I think it's really important for those adolescents to solve their own problems so they're not giving the learned helplessness that we see in these young people. This gives them a chance to own it and really focus on real world experiences. Mario, do you want to go next on how you'd implement that?
Sure. I agree exactly with how you put it. Using real world examples for mathematics gives them a chance to, not only show their comprehension of content, but also we can use those real world examples to help them show modeling and enrichment activities to further expand their understanding of the content. So I think that's also very important with how we implement that process into our practice, enrichment.
I would agree also with you all. Similar to what I said, like I was just saying for myself, I already value students exploring and making sense of math. So the process alone of with implemented the design process, it gives the process a clear pathway. Where they can act, imagine, plan, create, test, and basically improve. Which goes along with everything that we've said. I feel like our role shifts from just a delivering content thing to facilitating thinking. More so. Actually providing ideas that can be sparked upon. And yeah, just we can, as far as for myself, asking guiding questions instead of giving answers, allowing students to struggle productively, I said, while still supporting them. So, just in that aspect of, like you said, it's different than, just handing everything out versus handing everything out like it's done for you versus a blueprint, or a manual, therefore, where you really still got to use your own cognitive thinking. So that's how I feel, and I definitely agree with you all's aspects of it.
Martin, how would you implement it in your own practice?
Um, well, to be honest with you, for me, it's actually harder because I am a phys ed teacher.
Hmm.
So um, implementing a lot of these things become a little bit more, I would say, on a difficult aspect because the being in a gym scenery is so much different than anything else,
Definitely.
and
Yeah, it's not like a
yeah,
traditional classroom.
yeah, and I've been trying to implement a lot of things, but it becomes difficult because even when I break down my groups, um, you can't like give too much time to one group to than the other. So a lot of things that I'll be wanting to implement is just like, all right, how can I do it just as a large group,
Broader
so
thing,
my
yeah.
my scenery is a little bit different from a whole STEM aspect, you know.
Yeah,
Yeah.
I
Um,
still think that's unique. Like I said, with us just collaborating, I feel like you said, that's tailored to your position and what you do versus me. I teach mathematics. I work with RTI students from sixth to eighth grade, so it's like I said, a different aspect of it all. But still makes sense in as far as like I said, with struggles or making it being easier depending on our classroom setting.
yeah, yeah. I think the setting aspect of it is it's a
A
little
lot
technical.
different.
Yeah,
Gotcha.
yeah.
All right. I think we touched on all the points. I'll message Cambrian.
The engineering design process is an important instructional strategy in STEM because it encourages problem solving, critical thinking, and real world applications of knowledge. Unlike traditional instruction, it allows students to actively identify problems, design solutions, test ideas, and improve outcomes. This process also connects science, technology, engineering, and mathematics, helping teachers create meaningful cross disciplinary learning experiences while preparing students with important 21st century skills like collaboration, innovation, and analytical thinking. The engineering design process is a structured method students use to solve problems through the steps ask, imagine, plan, create, test, and improve. In the classroom, students can work in teams to solve real world challenges such as designing a water filtration system while applying scientific concepts, mathematical calculations, and technology tools.